Okay, we have a plane flying 10,500 feet above level ground. So here's our airplane. Oh, well, I want to be able to draw my airplane. So here's my airplane. It's got wings. It looks like something. So I've got my airplane, and he's flying above level ground, and there's a tree over here. Here's my tree. It's green. And we want to know, I don't know why that won't go away. It's bugging me. There. Now I have other problems, but I got rid of the dot. There we go. Okay, so I got my little plane that doesn't look like a plane, but it's something over there. We're pretending it's a plane. And the angle of depression, so here he's flying above level ground, so we're assuming that this is a nice straight line. I didn't draw a straight line, but we're assuming it's a nice straight line. And he's 10,500 feet up in the air. And the angle of depression from the plane to the base of the tree, so down to there, we're saying that the angle of depression, so the angle of depression, here's the horizon, line of sight, angle of depression is right here, 13 degrees, 50 minutes. How far horizontally must the plane fly to be directly above the tree? So we want to know when will it get here. So we want to know this dotted line distance, but that distance is the same as the black distance. It's important to remember here. That's the whole level ground thing. Okay, so the idea here is we can find either one of them, which is going to be useful. We know that's a right triangle, that's a right angle, because you know we're hoping we're straight up from the ground. We've got a vertical line here. This angle right here, since this is horizons are straight, this is another right angle, which means I can figure out what this is. This is 90 minus 13 degrees, 50 minutes. And I forgot to open up my calculator. So you get to see me find my calculator here. Right here. Okay, so we have a calculator. Now, when I come back here, and you can see I've got my picture here, so I need to figure this out. Now, I could do this in my head, but remember we've got our calculator, and our calculator is useful. I'm going to change to degrees, because I'm going to need degrees as I work through this. So I'm going to do 90 degrees minus 13 degrees, 50 minutes. There's my minutes. Okay, now I could convert this back, but I'm going to leave it in decimal degrees, and I'm going to leave that right there in the calculator. So I'm about 76.2 degrees up there. But I'm not rounding because I don't want to round to the end, but approximately to put it in there. Then what I'm going to do is I need to find this over here, right? Well, I already know this 10,500, so I know my two legs. So it's going to be easiest for me to use the tangent. So the tangent of 76.2 equals opposite x over adjacent 10.5. So that means x, what I'm looking for, is 10,500 times the tangent of 76.2. And so now, the reason I left this all in my calculator is I'm going to come back here, and I'm going to take this tangent. I'm going to go tangent of my answer, so I never had to round, because your goal is not to have to round until you get to the very end, unless there's some, reason you can't, but you always want to not round, so I didn't round. And then I'm going to take this answer times my 10,500. So now there I am, 42,641 feet, but significant digits, it wants us to round the same as our 10.5, so we're going to round this to 42.6. So x is 42 600 feet. Okay, and that's if I actually came back here, because remember significant digits here. If I came back and I did this 30 degrees, 50 minutes, if I click the right button, you can see this is 13.83. And so they're pretty much calling this 3 significant digits, this 13 and then 50. They're saying you probably round it to the nearest 10 minutes. It really doesn't matter that much. You're more matching it to what they want. In this case, they're matching it to the feet, but they're gonna tell you what to round to. And I'm a little bit more generous. I'm gonna probably, like, if you'd given me 641 feet, I'm also okay with that. But this is the answer they had with their rounding. But you can see here, the big thing when you're setting these up, get this picture drawn, whether it's a good picture or a horrible picture like mine. Yours is probably better than mine. You really can't get much worse. The important thing is to figure out where your angles are and make sure that, like, your angle of depression, your angle of elevation are right. And then once you have that picture, then you can go, okay, what pieces can I figure out? What trig relationship can I set up? And really remember, you're focusing on sine, cosine, and tangent. I mean, obviously you could use the other three, but those are going to be the easiest to use. They're already in your calculator. They're going to be nice and simple to work with.